I wasn't recorded. Okay, so we're starting out here at section 3.2, which is exploring the relationships between sets. This will be a lot quicker than the previous ones. Like I said, all this learning is built on 3.1. So let's start out here. Get this in your book, what I have on highlighted on the right side of my screen. So 3, 2, 1. All right. So in an Alberta school, there are 65 grade 12 students. We have 65 people who are taking a survey. Of these students, 23 play volleyball, 26 play basketball, and there are 31 students who do not play either sport. And this Venn diagram here breaks it out. How can you use this Venn diagram to determine the number of students who play only volleyball, only basketball, both sports, and no sports? Why is this a complicated thing? Why is this something that needs consideration? Well, it's saying that there's 23 people who play volleyball, there's 26 people who play basketball, and there's 31 people who don't play either of them. Now, if you add all of those numbers up, you're going to actually end up getting up. There are 80 people. There's 80 data sets here. Sorry, there's 80 data points. Okay? But there was only 65 people here, which means, right? So if there's 80 data points and there's 65 people, well, that means that we have 15 that are overlapped, right? What that means is 15 people actually play both. Now, if we're looking at people who play neither sports, we have volleyball here, our blue one. We have basketball, our right one here. Well, we have 31 people who play no sports, so they're outside of these. So they are outside of these entirely. So here's what else we know. If I take all the people who play volleyball, I know there's 23 people who play volleyball. I also know there's 26 people who play basketball, right? Now here's the problem. I'm taking this data set and I'm saying this is 23 plus 15. Actually, let me give a nice visual here. Right? So this data set right now is wrong because it's saying I'm taking 23 people who play volleyball plus 15 people who play both plus 26 people who play basketball plus 31 people in total. Now I have 95. What? What's going on? What's the issue here? Where have I made a mistake? Where is there a mistake? These. Because remember, some of these people are filtered in there. Some of these people are filtered in there. Some people play both. 15 people play both. So actually, we know at least 15 of our volleyball players also play basketball, which means there's 8 people who only play volleyball, right? 8 people who only play volleyball. Likewise, I know there's 15 basketball players who play volleyball, which means there's 11 people who only play basketball. And now if I add those figures up, 8 plus 15 plus 11 plus 31, I've categorized all 65 of my youth in this case. So the math itself isn't hard here, guys, right? But you have to follow some set logic. You have to have some problem solving here. And sometimes that means you might make a mistake. You might put something in and it's wrong. So the big thing you need to do here is check your work, right? Really easy to make some mistakes here. Now I do want you to get these key ideas in here. So quickly draw this in your book, pause the video, draw this in, organize it exactly how you see here. So 3, 2, 1. Okay, so I'm assuming you have this in here. So So sets that are not disjoint. Oh crap, what's disjoint? What's disjoint? Go back up your notes. Two or more sets that have nothing in common. So sets that, oh God, this is worded badly. Sets that are not sets that are not nothing in common. Jesus. Sets that are not nothing in common share certain elements. What a crappy sentence. Can we reword that? Sets sets that are not completely separate share common elements. We'll say that. Each area of the Venn diagram represents something different. And then when two non-disjoint sets are represented by a diagram, which means like these they have some overlap. When two sets which have some overlap are represented in a Venn diagram, you can count the elements in both sets by counting the elements in each region of the diagram just once. That's pretty fancy smanchy. Honestly, your eyes should be on the picture. If you understand the picture, you understand it logically, and that's all you need. So this section here, let me use the same colors they're using. Purple, 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 sure. So first off, if you are in both basketball and volleyball, you are in both of them, right? We would say this is the intersection. If you're in the crap, if you're in volleyball here, you are in the element B, but not you're in set B, but not in set A, right? You only play volleyball, for example. Same thing over here. You only play basketball. And then elements that are in U, so they're part of this, but they're not in set A or B. They play no sports. Are not in set A or B, right? So you see that little U there, right? Just like up here, here's all of our grade 12 students. This is the entire data set. So they're just presumed to be in here. Couple key notes. Each element in a set only appears once, okay? Only appears once. I didn't include the people from the intersection from this purple part in A. They're not there. They play both. They're in their own little subset. If an element occurs in more than one set, it is placed in the Venn diagram where the set overlaps or intersects. That's going to come into play later on in here. Anything else I want to do? I don't think so. I think at this point you guys are pretty good to be able to handle this stuff, but if you're not, let me know. But yeah, that's 3.2 in a nutshell. It's really not that deep. I don't think I need to go over more. No, I think you guys are good there. Okay, so with that said, finish up 3.2 textbook and workbook. Good news, it's a lot quicker. So you're good to go. And then do the assignment. Awesome. Good job, guys.